Hello and welcome. In this course, you will explore relational data in Microsoft Azure. To begin with, you will identify relational Microsoft Azure data services and explore the considerations in choosing a relational data service. Such topics include Azure SQL Database, Azure SQL Managed Instance, and SQL Server on Azure Virtual Machine. You will also learn how to provision and configure relational data services while exploring basic connectivity and some data security features. You will explore relational data offerings, provisioning, and deploying relational databases through cloud data solutions with Microsoft Azure. You will identify the various methods for deployment, such as the Microsoft Azure Portal, Azure Resource Manager templates, Azure PowerShell, and the Azure Command Line Interface, or CLI. Finally, you will compare data definition language, DDL, versus data manipulation language, DML, while also querying relational data in Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. Hello and welcome. In this course, you will explore relational data in Microsoft Azure. A database is a collection of data. A database can be as simple as a traditional spreadsheet or as complex as a global system holding petabytes of highly structured information. The data can be structured in many different ways. A common approach is to store data in a tabular format made up of rows and columns. You can define relationships by using common fields between the tables. These databases are called relational databases. Databases can also be semi-structured or unstructured, comprising of semi-processed or unprocessed data. These databases are typically referred to as non-relational. Databases are managed using a database management system, or a DBMS for short. The DBMS handles the physical aspects of a database, such as where and how it's stored, who can access it, and how to ensure that it's available when required. Many organizations depend on the information stored in their databases to help make critical business decisions. In the past, these organizations ran their DBMSs on premises. However, this approach requires the organization to maintain its own hardware infrastructure. Therefore, an increasing number of businesses are migrating their databases to the cloud, where the costs of configuring and maintaining the infrastructure are highly reduced. Suppose you're a database administrator at Wide World Importers. You're responsible for database design and maintenance, as well as providing information for management and creating customer lists for the marketing department. You have an existing SQL Server database that relies heavily on stored procedures and other advanced database features, such as linked servers. The database is situated on your internal network. You've been asked to make it globally available to your partners worldwide. It's important to note that a stored procedure is a block of code that runs inside your database. Applications often use stored procedures because they are optimized to run in the database environment and can access data very quickly. A linked server is a connection from one database server to another. SQL Server can use linked servers to run queries on one server that can include data retrieved from another server as part of its result set. These are known as distributed queries. In this lesson, you'll explore the options available when choosing a relational data platform for hosting a database in Microsoft Azure. You will identify relational Microsoft Azure data services and explore considerations in choosing a relational data service. Microsoft Azure offers a range of options for running a database management system in the cloud. For example, you can migrate your on-premises system to a collection of Azure virtual machines. This approach still requires that you manage your DBMS carefully. Alternatively, you can take advantage of the various Azure relational data services available. These data services manage the DBMS for you, leaving you free to concentrate on the data they contain and the applications that use them. Let's take a quick look at what exactly is an Azure Virtual Network. An Azure Virtual Network is a representation of your own network in the cloud. A virtual network enables you to connect virtual machines and Azure services together, in much the same way that you might use a physical network on premises. Azure ensures that each virtual network is isolated from other virtual networks created by other users and from the internet. Azure enables you to specify which machines, real and virtual, and services are allowed to access resources on the virtual network and which ports they can use. Before delving into Azure Data Services, you need to understand some common terms used to describe the different ways in which you can host a database in Azure. These include the common terms IaaS, PaaS, and SaaS. IaaS is an acronym for Infrastructure as a Service. Azure enables you to create a virtual infrastructure in the cloud that mirrors the way an on-premises data center might work. You can create a set of virtual machines, connect them together using a virtual network, and add a range of virtual devices. You take responsibility for installing, configuring, and maintaining the software, such as the DBMS, on these virtual machines. In many ways, this approach is similar to the way in which you run your systems inside an organization, except that you don't have to concern yourself with buying or maintaining the hardware. PaaS stands for a Platform as a Service. Rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS solution does this for you. You specify the resources that you require based on how large you think your databases will be, the number of users, and the performance you require, and Azure automatically creates and manages the necessary virtual machines, networks, and other devices for you. You can usually scale up or down, increase or decrease the size and number of resources quickly, as the volume of data and the amount of work being done varies. Azure handles this scaling for you, and you don't have to manually add or remove virtual machines or perform any other form of configuration. SaaS is short for Software as a Service. SaaS services are typically specific software packages that are installed and run on virtual hardware in the cloud. SaaS packages are typically hosted applications rather than more generalized software such as a DBMS. Common SaaS packages available on Azure include Microsoft 365, formerly Office 365. IaaS is the most flexible category of cloud services. It aims to give you complete control over the hardware that runs your application. Instead of buying hardware, with IaaS, you rent it. PaaS provides the same benefits and considerations as IaaS, but there are some additional benefits such as database management and operating systems. SaaS is software that's centrally hosted and managed for you and your users and customers. Usually one version of the application is used for all customers and it's licensed through a monthly or annual subscription. SaaS provides the same benefits as IaaS, but again, there are some additional benefits such as apps. You can see how when you move from IaaS to PaaS to SaaS, the shared responsibilities reduces for the client and increases for the provider. Azure Data Services fall into the PaaS category. These services are a series of DBMSs managed by Microsoft in the cloud. Each data service takes care of the configuration, day-to-day management, software updates, and security of the databases that it hosts. All you do is create your databases under the control of the data service. Azure Data Services are available for several common relational database management systems. The most well-known service is Azure SQL Database. The others currently available are Azure Database for MySQL servers, Azure Database for MariaDB servers, and Azure Database for PostgreSQL servers. The remaining lessons in this section will describe the features provided by these services. It's important to note that Microsoft also provides data services for non-relational database management systems, such as Cosmos DB. Using Azure Data Services reduces the amount of time that you need to invest to administer a DBMS. However, these services can also limit the range of custom administration tasks that you can perform, because manually performing some tasks might risk compromising the way in which the service runs. For example, some DBMSs enable you to install custom software into a database or run scripts as part of a database operation. This software might not be supported by the data service, and allowing an application to run a script from a database could affect the security of the service. You must be prepared to work with these restrictions in mind. Apart from reducing the administrative workload, Azure Data Services ensure that your databases are available for at least 99.99% of the time. It's important to note that there are costs associated with running a database in Azure Data Services. The base price of each service covers underlying infrastructure and licensing, together with the administration charges. Additionally, these services are designed to be always on. This means that you cannot shut down a database and restart it later. Not all features of a database management system are available in Azure Data Services. This is because Azure Data Services takes on the task of managing the system and keeping it running using hardware situated in an Azure data center. Exposing some administrative functions might make the underlying platform vulnerable to misuse and even open up some security concerns. Therefore, you have no direct control over the platform on which the services run. If you need more control than Azure Data Services allow, you can install your database management system on a virtual machine that runs in Azure using IaaS. Later, you will examine this approach in more detail for SQL Server, although the same concerns apply for the other database management systems supported by Azure Data Services. There are benefits and trade-offs when running a database management system with SQL Server. For example, administrative efforts against capital expenditure and day-to-day control for on-premises IaaS and PaaS approaches. The physical on-premises solution requires higher capital expenditure, but the greatest level of physical control. This is compared to using virtual machines in Azure, IaaS approach, or Azure SQL Database, PaaS approach. The PaaS solution requires the lowest administrative effort and capital expenditure. The same generalized considerations are true for other database management systems. Microsoft SQL Server is a popular relational DBMS. It has a long history and has features that provide database management to organizations of all sizes. In the past, organizations have run SQL Server on-premises. However, many organizations are now looking to shift operations online to take advantage of services available in the cloud. SQL Server offers several ways to run a database in Azure. In this lesson, you'll look at moving SQL Server to an Azure virtual machine. SQL Server on virtual machines enables you to use full versions of SQL Server in the cloud without having to manage any on-premises hardware. This is an example of the IaaS approach. SQL Server running on an Azure virtual machine effectively replicates the database running on real on-premises hardware. Migrating from the system running on-premises to an Azure virtual machine is no different than moving the databases from one on-premises server to another. In the example scenario described earlier, the database runs stored procedures and scripts as part of the database workload. If these stored procedures and scripts depend on features that are restricted by following a PaaS approach, then running SQL Server on your own virtual machines might be a good option. However, you remain responsible for maintaining the SQL Server software and performing the various administrative tasks to keep the database running from day to day. This approach is suitable for migrations and applications requiring access to operating system features that might be unsupported at the PaaS level. SQL virtual machines are lift and shift ready for existing applications that require fast migration to the cloud with minimal changes. It's important to note that the term lift and shift refers to the way in which you can move a database directly from an on-premises server to an Azure virtual machine without requiring that you make any changes to it. Applications that previously connected to the on-premises database can be quickly reconfigured to connect to the database running on the virtual machine, but should otherwise remain unchanged. This approach is optimized for migrating existing applications to Microsoft Azure or extending existing on-premises applications to the cloud in hybrid deployments. A hybrid deployment is a system where part of the operation runs on-premises and part in the cloud. Your database might be part of a larger system that runs on-premises, although the database elements might be hosted in the cloud. For example, a client machine running an app connecting to SQL Server in the cloud and other resources on-premises. You can use SQL Server in a virtual machine to develop and test traditional SQL Server applications. With a virtual machine, you have full control of and administrative rights over the DBMS and operating system. It's a perfect choice when your organization already has IT resources available to maintain the virtual machines. These capabilities enable you to create rapid development and test scenarios when you do not want to buy on-premises non-production SQL Server hardware. Become lift and shift ready for existing applications that require fast migration to the cloud with minimal changes or no changes. Scale up the platform on which SQL Server is running by allocating more memory, CPU power, and disk space to the virtual machine. You can quickly resize an Azure virtual machine without the requirements that you reinstall the software that is running on it. Running SQL Server on virtual machines allows you to meet unique and diverse business needs through a combination of on-premises and cloud-hosted deployments, while using the same set of server products, development tools, and expertise across these environments. However, it's not always easy for businesses to switch their DBMS to a fully managed service. There may be specific requirements that must be satisfied in order to migrate to a managed service that requires making changes to the database and the applications that use it. For this reason, using virtual machines can offer a solution, but using them does not eliminate the need to administer your DBMS as carefully as you would on premises. If you don't want to incur the management overhead associated with running SQL Server on a virtual machine, you can use Azure SQL Database. Azure SQL Database is a PaaS offering for Microsoft. You create a managed database server in the cloud and then deploy your databases on this server. A SQL database server is a logical construct that acts as a central administrative point for multiple single or pooled databases, logins, firewall rules, auditing rules, threat detection policies, and failover groups. Azure SQL Database is available with several options: single database, elastic pool, and managed instance. The following sections describe single database and elastic pool. Managed instance is the subject of the next lesson. Let's start with single database. This option enables you to quickly set up and run a single SQL Server database. You create and run a database server in the cloud, and you access your database through this server. Microsoft manages the server, so all you have to do is configure the database, create your tables, and populate them with your data. You can scale the database if you need additional storage space, memory, or processing power. By default, resources are pre-allocated and you're charged per hour for the resources you've requested. You can also specify a serverless configuration. In this configuration, Microsoft creates its own server, which might be shared with a number of databases belonging to other Azure subscribers. Microsoft ensures the privacy of your database. Your database automatically scales and resources are allocated or deallocated as required. For more information, read "What is a single database in Azure SQL Database?" There is a link to this document from the additional readings at the end of this lesson. This is an example of an Azure SQL Database single database deployment. The Azure resources are managed by the server, such as disks, memory, and processors. Let's take a look at the elastic pool model now. The elastic pool option is similar to single database, except that by default, multiple databases can share the same resources, such as memory, data storage space, and processing power. The resources are referred to as a pool. You create the pool, and only your databases can use the pool. This model is useful if you have databases with resource requirements that vary over time and can help you to reduce costs. For example, your payroll database might require plenty of CPU power at the end of each month as you handle payroll processing, but at other times the database might become much less active. You might have another database that is used for running reports. This database might become active for several days in the middle of the month as management reports are generated, but with a lighter load at other times. Or you can have an Azure SQL Database Elastic Pool deployment. The pooled resources are shared by all databases. Elastic Pool enables you to use the resources available in the pool and then release the resources once processing has completed. Azure SQL Database gives you the best option for low costs with minimal administration. It is not fully compatible with on-premises SQL Server installations. It's often used in new cloud projects where the application design can accommodate any required changes to your applications. You can use the Data Migration Assistant to detect compatibility issues with your databases that can impact database functionality in Azure SQL Database. For more information, see Overview of Data Migration Assistant. There is a link to this document from the additional readings at the end of this lesson. Azure SQL Database is often used for modern cloud applications that need to use the latest stable SQL Server features, applications that require high availability, and systems with a variable load that need the database server to scale up and down quickly. Let's now take a look at some of the business benefits associated with Azure SQL Database. These include automatic software patches and updates. Azure SQL Database automatically updates and patches the SQL Server software to ensure that you are always running the latest and most secure version of the service. Scale when needed. The scalability feature of Azure SQL Database ensures that you can increase the resources available to store and process data without having to perform a costly manual upgrade. High availability guarantees. The service provides high availability guarantees to ensure that your database are available at least 99.99% of the time. Azure SQL Database supports point-in-time restore, enabling you to recover a database to the state it was in at any point in the past. Databases can be replicated to different regions to provide additional assurance and disaster recovery. Advanced threat protection. Advanced threat protection provides advanced security capabilities, such as vulnerability assessments, to help detect and remediate potential security problems with your databases. Threat protection also detects anomalous activities that indicate unusual and potentially harmful attempts to access or exploit your database. It continuously monitors your database for suspicious activities and provides immediate security alerts on potential vulnerabilities, SQL injection attacks, and anomalous database access patterns. Threat detection alerts provide details of the suspicious activity and recommend action on how to investigate and mitigate the threat. Tracking for auditing and compliance. Auditing tracks database events and writes them to an audit log in your Azure storage account. Auditing can help you maintain regulatory compliance, understand database activity, and gain insight into discrepancies and anomalies that might indicate business concerns or suspected security violations. Security with encryption. SQL Database helps secure your data by providing encryption. For data in transit, it uses transport layer security. For data at rest, it uses transparent data encryption. For data in use, it uses always encrypted. For more information on transport layer security, transparent data encryption, and always encrypted, see the link at the end of this lesson. In the wide world importer scenario, linked servers are used to perform distributed queries. However, neither single database nor Elastic Pool support linked servers. If you want to use single database or Elastic Pool, you may need to modify the queries that use linked servers and rework the operations that depend on these features. A business may want to eliminate as much management overhead as possible from administrating databases and servers, but the limitation of the single database and Elastic Pool options may mean that those options aren't suitable. In these situations, Azure SQL Database Managed Instance may be a good choice to consider. The single database and Elastic Pool options restrict some of the administrative features available to SQL Server. Managed Instance effectively run a fully controllable instance of SQL Server in the cloud. You can install multiple databases on the same instance. You have complete control over this instance, much as you would for an on-premises server. The Managed Instance service automates backups, software patching, database monitoring, and other general tasks, but you have full control over security and resource allocation for your databases. You can find detailed information on what is Azure SQL Database Managed Instance. You can find a link to this document from the additional readings at the end of this lesson. Managed instances depend on other Azure services such as Azure Storage for backups, Azure Event Hubs for telemetry, Azure Active Directory for authentication, Azure Key Vault for transparent data encryption, TDE, and a couple of Azure Platform services that provide security and supportability features. The managed instances make connections to these services. All communications are encrypted and signed using certificates. To check the trustworthiness of communicating parties, managed instances constantly verify certificates through certificate revocation lists. If the certificates are revoked, the managed instance closes the connections to protect the data. Let's summarize the differences between SQL Database Managed Instance, Single Database, and Elastic Pool. Managed Instance is an instance-scoped programming model with high compatibility with SQL Server. It's best for modernization at scale with low cost and low effort. Single Instance is a standalone managed database for predictable and stable workloads. Finally, Elastic Pool is a shared resource model for greater efficiency through multi-tenancy. Consider Azure SQL Database Managed Instance if you want to lift and shift an on-premises SQL Server instance and all its databases to the cloud without incurring the management overhead of running SQL Server on a virtual machine. SQL Database Managed Instance provides features not available with the single database or Elastic Pool options. If your system uses features such as linked servers, service broker, which is a message processing system that can be used to distribute work across servers, or database mail, which enables your database to send email messages to users. Then you should use managed instance. To check compatibility with an existing on-premises system, you can install Data Migration Assistant, or DMA. This tool analyzes your databases on SQL Server and reports any issues that could block migration to a managed instance. There is a link to this document from the additional readings at the end of this lesson. SQL Database Managed Instance provides all the management and security benefits available when using single database and elastic pool. Managed instance deployment enables a system administrator to spend less time on administrative tasks because the SQL database service either performs them for you or greatly simplifies those tasks. Automated tasks include operating system and database management system software installation and patching, dynamic instance resizing and configuration, backups, database replication, including system databases, high availability configuration, and configuration of health and performance monitoring data streams. Managed Instance has nearly 100% compatibility with SQL Server Enterprise Edition running on premises. The SQL Database Managed Instance deployment option supports traditional SQL Server Database Engine logins and logins integrated with Azure Active Directory. Traditional SQL Server Database Engine logins include a username and a password. You must enter your credentials each time you connect to the server. Azure AD logins use the credentials associated with your current computer's sign-in, and you don't need to provide them each time you connect to the server. In the wide world importer scenario, SQL Database Managed Instance may be a more suitable choice than single database or elastic pool. SQL Database Managed Instance supports linked servers, although some of the other advanced features required by the database might not be available. If you want a complete match, then running SQL servers on a virtual machine may be your only option, but you need to balance the benefits of complete functionality against the administrative and maintenance overhead required. As well as Azure SQL Database, Azure Data Services are available for other popular SQL-based database solutions. Currently, data services are available for MySQL, MariaDB, and PostgreSQL. The primary reason for these services is to enable organizations running MySQL, MariaDB, and PostgreSQL to move to Azure quickly without making wholesale changes to their applications. MySQL, MariaDB, and PostgreSQL are relational database management systems that are tailored for different specializations. Let's take a closer look at each now. MySQL started life as a simple-to-use open-source database management system. It is the leading open-source relational database for Linux, Apache, MySQL, and PHP LAMP stack apps. It's available in multiple editions: Community, Standard, and Enterprise. The Community Edition is available free of charge and has historically been popular as a database management system for web applications running under Linux. Versions are also available for Windows. Standard Edition offers higher performance and uses a different technology for storing data. Enterprise Edition provides a comprehensive set of tools and features, including enhanced security, availability, and scalability. The Standard and Enterprise Editions are the versions most frequently used by commercial organizations, although these versions of the software aren't free. MariaDB is a newer database management system created by the original developers of MySQL. The database engine has since been rewritten and optimized to improve performance. MariaDB offers compatibility with Oracle Database, another popular commercial database management system. One notable feature of MariaDB is its built-in support for temporal data. A table can hold several versions of data, enabling an application to query the data as it appeared at some point in the past. PostgreSQL is a hybrid relational object database. You can store data in relational tables, but a PostgreSQL database also enables you to store custom data types with their own non-relational properties. The database management system is extensible. You can add code modules to the database, which can be run by queries. Another key feature is the ability to store and manipulate geometric data, such as lines, circles, and polygons. PostgreSQL has its own query language called PGSQL. This language is a variant of the standard relational query language SQL, with features that enable you to write stored procedures that run inside the database. Azure Database for MySQL is a PaaS implementation of MySQL in the Azure cloud, based on the MySQL Community Edition. The Azure Database for MySQL service includes high availability at no additional cost and scalability as required. You only pay for what you use. Automatic backups are provided with point-in-time restore. The server provides connection security to enforce firewall rules and optionally require SSL connections. Many server parameters enable you to configure server settings such as lock modes, maximum number of connections, and timeouts. Azure Database for MySQL provides a global database system that scales up to large databases without the need to manage hardware, network components, virtual servers, software patches, and other underlying components. Certain operations aren't available with Azure Database for MySQL. These functions are primarily concerned with security and administration. Azure manages these aspects of the database server itself. The system uses pay-as-you-go pricing, so you only pay for what you use. Azure Database for MySQL servers provides monitoring functionality to add alerts and to view metrics and logs. Azure Database for MariaDB is an implementation of the MariaDB database management system adapted to run in Azure. It's based on the MariaDB Community Edition. The database is fully managed and controlled by Azure. Once you've provisioned the service and transferred your data, the system requires almost no additional administration. Azure Database for MariaDB delivers built-in high availability with no additional cost, predictable performance using inclusive pay-as-you-go pricing, scaling as needed within seconds, secured protection of sensitive data at rest and in transit, automatic backups and point-in-time restore for up to 35 days, and enterprise-grade security and compliance. If you prefer PostgreSQL, you can choose Azure Database for PostgreSQL to run a PaaS implementation of PostgreSQL in the Azure cloud. This service provides the same availability, performance, scaling, security, and administrative benefits as the MySQL service. Some features of on-premises PostgreSQL databases are not available in Azure Databases for PostgreSQL. These features are mainly concerned with the extensions that users can add to a database to perform specialized tasks, such as writing stored procedures in various programming language, other than PG-SQL, which is available, and interacting directly with the operating system. A core set of the most frequently used extensions is supported, and the list of available extensions is under continuous review. Azure Database for PostgreSQL has two deployment options, single server and hyperscale. The single server deployment option for PostgreSQL provides similar benefits as Azure Database for MySQL. You choose from 3 pricing tiers: Basic, General Purpose, and Memory Optimized. Each tier supports different numbers of CPUs, memory, and storage sizes. You select one based on the load you expect to support. Hyperscale Citus is a deployment option that scales queries across multiple server nodes to support large database loads. Your database is split across nodes. Data is split into chunks based on the value of a partition key or a sharding key. Consider using this deployment option for the largest database PostgreSQL deployments in the Azure cloud. Azure Database for PostgreSQL is a highly available service. It contains built-in failure detection and failover mechanisms. Users of PostgreSQL will be familiar with the PG admin tool, which you can use to manage and monitor a PostgreSQL database. You can continue to use this tool to connect to Azure Database for PostgreSQL. However, some server-focused functionality, such as performing server backup and restore, are not available because the server is managed and maintained by Microsoft. Azure Database for PostgreSQL servers record information about the queries run against databases on the server and saves them in a database named Azure_SYS. You query the query_store.qs_view to see this information and use it to monitor the queries that users are running. This information can prove invaluable if you need to fine-tune the queries performed by your applications. If you have existing MySQL, MariaDB, or PostgreSQL databases running on-premises, and you want to move the data to a database running the corresponding data services in Azure, you can use the Azure Database Migration Service, or DMS. The Database Migration Service enables you to restore a backup of your on-premises databases directly to databases running in Azure Data Services. You can also configure replication from an on-premises database so that any changes made to data in the database are copied to the database running in Azure Data Services. This strategy enables you to reconfigure users and applications to connect to the database in the cloud while the on-premises system is still active. You don't have to shut down the on-premises system while you transfer users to the cloud. In this lesson, you've learned about the PaaS and IaaS deployment options for running databases in the cloud. You've seen how Azure Data Services provide a range of PaaS services for running relational databases in Azure. You've learned how the PaaS options provide support for automated management and administration, compared to an IaaS approach. Hello! In this lesson, you will learn how to provision and configure Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. Microsoft Azure supports a number of database services, enabling you to run popular database management systems such as SQL Server, PostgreSQL, and MySQL in the cloud. Microsoft Azure database services are fully managed, freeing up valuable time you'd otherwise spend managing your database. Enterprise-grade performance with built-in high availability means you can scale quickly and reach global distribution without worrying about costly downtime. Developers can take advantage of industry-leading innovations such as built-in security with automatic monitoring and threat detection, and automatic tuning for improved performance. On top of all these features, you have guaranteed availability. Suppose you're a data engineer at Contoso and are responsible for creating and managing databases. You've been asked to set up 3 new relational data stores: Azure SQL Database, PostgreSQL, and MySQL. In this lesson, you'll explore the options available for creating and configuring Microsoft Azure Relational Data Services. In this lesson, you will provision relational data services, configure relational data services, explore basic connectivity issues, and explore data security. In this sample scenario, Contoso has decided that the organization will require several different relational stores. As the data engineer, you've been asked to set up data stores using Azure SQL Database, PostgreSQL, and MySQL. In this lesson, you'll learn how to provision these services. Provisioning is the act of running a series of tasks to create, configure, and make available a service, such as Azure SQL Database. Behind the scenes, the service provider will set up various resources, disks, memory, CPUs, networks, and so on, required to run the service. You'll be assigned these resources, and they remain allocated to you and charged to you until you delete the service. How the service provider provisions resources is opaque, and you don't need to be concerned with how this process works. All you do is specify parameters that determine the size of the resources required, how much disk space, memory, computing power, and network bandwidth. These parameters are determined by estimating the size of the workload that you intend to run using the service. In many cases, you can modify these parameters after the service has been created, perhaps increasing the amount of storage space or memory if the workload is greater than you initially anticipated. The act of increasing or decreasing the resources used by a service is called scaling. This example demonstrates the process that Microsoft Azure performs when you provision a service. First, the user specifies the provisioning parameters, such as the type of service, storage, memory, and compute power. The provisioning parameters are then sent to Microsoft Azure to provision the service. Azure allocates the necessary resources to create the service. Finally, the service is then ready for use. Microsoft Azure provides several tools you can use to provision services. These include the Microsoft Azure Portal, Azure Command Line Interface, CLI, Azure PowerShell, and Azure Resource Manager templates. Let's take a brief look at each of these now. The Microsoft Azure Portal is the most convenient way to provision a service for most users. It displays a series of service-specific pages that prompt you for the settings required and validates these settings before actually provisioning the service. The Azure Command Line Interface, or CLI, provides a set of commands that you can run from the operating system command prompt or the Cloud Shell in the Microsoft Azure Portal. You can use these commands to create and manage Microsoft Azure resources. The CLI is suitable if you need to automate service creation. You can store CLI commands in scripts, and you can run these scripts programmatically. The CLI can run on Windows, Mac OS, and Linux computers. For detailed information about the Azure CLI, read What is Azure CLI on the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Many administrators are familiar with using Azure PowerShell commands to script and automate administrative tasks. Azure provides a series of commandlets, Azure-specific commands, that you can use in PowerShell to create and manage Azure resources. Like the CLI, PowerShell is available for Windows, Mac OS, and Linux. You can find further information about Azure PowerShell online at Azure PowerShell documentation page. There is a link to this document from the additional readings at the end of this lesson. Let's take a look at Azure Resource Manager templates now. An Azure Resource Manager, or ARM template, describes the service or services that you want to deploy in a text file, in a format known as JSON, which is short for JavaScript Object Notation. Using JSON, you can define the infrastructure and configuration for your project. This example in JSON format shows a template that you can use to provision an instance of Azure SQL database. The JSON code describes and stores the configuration settings that will be applied. You send the template to Azure using the AZ deployment group create command in the Azure CLI or new-AZ resource group deployment command in Azure PowerShell. For more information about creating and using Azure Resource Manager templates to provision Azure resources, see What are Azure Resource Manager templates? Once again, you will find a link to this document in the additional readings at the end of this lesson. Microsoft Azure Relational Data Services enable you to work with other leading relational database providers, such as PostgreSQL and MySQL. These services are called Azure Database for PostgreSQL and Azure Database for MySQL. Now you'll see how to provision these data stores in Microsoft Azure. As with Azure SQL Database, you can provision a PostgreSQL or MySQL database interactively using the Azure portal. You can find both of these services in the Microsoft Azure Marketplace. The processes for provisioning Azure Database for PostgreSQL and Azure Database for MySQL are very similar. It's important to note, however, that PostgreSQL also gives you the hyperscale option, which supports ultra-high performance workloads. The hyperscale deployment option supports horizontal scaling across multiple machines. This option enables the service to add and remove computers as workloads increase and diminish. Query parallelization across these servers. The service can split resource-intensive queries into pieces which can be run in parallel on different servers. The results from each server are aggregated back together to produce a final result. This mechanism can deliver faster responses on queries over large data sets. Hyperscale also provides support for multi-tenant applications, real-time operational analytics, and high-throughput transactional workloads. This example summarizes the fields and settings required when provisioning a PostgreSQL or a MySQL database service. The Basic tab prompts for the following details, which is grouped in sections. First, you select your Microsoft Azure subscription. Next is Resource Group, where you either pick an existing resource group or select Create New to build a new one. Each MySQL or PostgreSQL database must have a unique name that hasn't been used publicly before. The name must be between 3 and 31 characters long and can only contain lowercase letters, digits, and the dash character. You enter this in the server name field. Select None to create a new server from scratch. You can select Backup if you're creating a server from a geo backup of an existing Azure database for MySQL Server. For location, either select the region that is nearest to you or the region nearest to your users. For version, you choose the version of MySQL or PostgreSQL to deploy. The Compute and Storage setting deals with the compute, storage, and backup configurations for your new server. The Configure Server link enables you to select the resources required to support your database workloads. These resources include the amount of computing power, memory, backups, and redundancy options for high availability. Let's explore this section in a little more detail now. It's also important to note that the term compute refers to the amount of processor power available, but in terms of size and number of CPUs allocated to the service. Let's take a closer look at this section now. You can select between 3 pricing tiers, each of which is designed to support different workloads. The basic tier is suitable for workloads that require light compute and I/O performance. Examples include servers used for development or testing, or small-scale and frequently used applications. Use the general purpose pricing tier for business workloads that require balanced compute and memory with scalable I/O throughput. Examples include servers for hosting web and mobile apps and other enterprise applications. Finally, the memory-optimized tier supports high-performance database workloads that require in-memory performance for faster transaction processing and higher concurrency. Examples include servers for processing real-time data and high-performance transactional or analytical apps. You can fine-tune the resources available for the selected tier. You can scale these resources up later if necessary. Let's switch back to the final section for provisioning a PostgreSQL or a MySQL database service. In the Administrator Account section, the admin username is the sign-in account to use when you're connecting to the server. It's important to note that the admin sign-in name can't be Azure_superuser, admin, administrator, root, guest, or public. Finally, the password and confirm password fields are where you provide a new password for the server admin account. It's important to note that the password must contain from 8 to 128 characters. And your password must contain characters from 3 of the following categories: English uppercase letters, English lowercase letters, numbers 0 through 9, and non-alphanumeric characters, $!, hashtag, percentage, and so on. The last step is to review, and once you've specified the appropriate settings, select the Review and Create button to provision the server. After you've provisioned a resource, you'll often need to configure it to meet the needs of your applications and environment. For example, you might need to set up network access or open a firewall port to enable your applications to connect to the resource. In this part, you'll learn how to enable network access to your resources and how you can prevent accidental exposure of your resources to third parties. You'll see how to use authentication and access control to protect the data managed by your resources. Now let's discuss how you can configure connectivity in firewalls. The default connectivity for Azure Relational Data Services is to disable access to the world. Now we will look at how to configure connectivity to virtual networks and on-premises computers. To enable connectivity, use the Firewalls and Virtual Networks page for a service. From the database page in the Azure portal, select Connection Security and then configure the firewall rules and access to the Azure service. It's important to note that an Azure Virtual Network is a representation of your own network in the cloud. A virtual network enables you to connect virtual machines and Microsoft Azure services together in much the same way that you might use a physical network on premises. Microsoft Azure ensures that each virtual network is isolated from other virtual networks created by other users and from the Internet. Microsoft Azure enables you to specify which machines, real and virtual, and services are allowed to access resources on the virtual network and which ports they can use. In the Virtual Networks section, you can specify which virtual networks are allowed to route traffic to the service. When you create items such as web applications and virtual machines, you can add them to a virtual network. If these applications and virtual machines require access to your resource, add the virtual network containing these items to the list of allowed networks. If you need to connect to the service from an on-premises computer, in the Firewall section, add the IP address of the computer. This setting creates a firewall rule that allows traffic from that address to reach the service. The Exceptions setting allows you to enable access to any other services that cannot be uniquely isolated through virtual network or IP address rules. For example, the Firewalls and Virtual Networks page for an Azure SQL database. MySQL and PostgreSQL have a similar page. Azure SQL Database communicates over port 1433. If you're trying to connect from within a corporate network, outbound traffic over port 1433 might not be allowed by your network's firewall. If so, you can't connect to your Azure SQL Database server unless your IT department opens port 1433. It's important to note that a firewall rule of 0.0.0.0 enables all Azure services to pass through the server-level firewall rule and attempt to connect to a single or pooled database through the server. Azure Private Endpoint is a network interface that connects you privately and securely to a service powered by Azure Private Link. Private endpoint uses a private IP address from your virtual network, effectively bringing the service into your virtual network. The service could be a Microsoft Azure service, such as Azure App Service, or your own private link service. For detailed information, read, "What is Azure Private Endpoint?" There is a link to this document from the additional readings at the end of this lesson. The Private Endpoint Connections page for a service allows you to specify which private endpoints, if any, are permitted access to your service. You can use the settings on this page together with the Firewalls and Virtual Networks page to completely lock down users and applications from accessing public endpoints to connect to your Azure SQL database account. Let's talk about how you can configure authentication now. With Azure Active Directory authentication, you can centrally manage the identities of database users and other Microsoft services in one central location. Central ID management provides a single place to manage database users and simplifies permission management. You can use these identities and configure access to your relational data services. For detailed information on using Azure AD with Azure SQL Database, you can visit the page "What is Azure Active Directory Authentication for SQL Database" on the Microsoft website. You can also authenticate users connecting to Azure Database for PostgreSQL and Azure Database for MySQL with AD. There is a link to these documents from the additional readings at the end of this lesson. Azure AD enables you to specify who or what can access your resources. Access control defines what a user or application can do with your resources once they've been authenticated. Access management for cloud resources is a critical function for any organization that is using the cloud. Azure Role-Based Access Control, Azure RBAC, helps you manage who has access to Microsoft Azure resources and what they can do with those resources. For example, using RBAC, you could allow one user to manage virtual machines in a subscription and another user to manage virtual networks. Allow a database administrator group to manage SQL databases in a subscription. Allow a user to manage all resources in a resource group, such as virtual machines, websites, and subnets, and allow an application to access all resources in a resource group. You control access to resources using Azure RBAC to create role assignments. A role assignment consists of 3 elements: a security principal, a role definition, and a scope. Let's look at these in a little more detail now. A security principal is an object that represents a user, group, service principal, or managed identity that is requesting access to Microsoft Azure resources. A role definition, often abbreviated to role, is a collection of permissions. A role definition lists the operations that can be performed, such as read, write, and delete. Roles can be given high-level names, like owner, or specific names, like virtual machine reader. Finally, a scope lists the set of resources that the access applies to. When you assign a role, you can further limit the actions allowed by defining a scope. This is helpful if, for example, you want to make someone a website contributor, but only for one resource group. Let's explore roles in a little more detail now. Microsoft Azure includes several built-in roles that you can use, including owner, who has full access to all resources, including the right to delegate access to others. Contributor, who can create and manage all types of Microsoft Azure resources, but can't grant access to others. Reader, who can view existing Microsoft Azure resources. And User Access Administrator, which lets you manage user access to Microsoft Azure resources. You can also create your own custom roles. For detailed information, see Create or Update Azure Custom Roles using the Azure portal on the Microsoft website. There is a link to this document from the additional readings at the end of this lesson. You add assignments to a resource in the Microsoft Azure portal using the Access Control IAM page. The Role Assignments tab enables you to associate a role with the security or service principal and define the level of access. For more information, you can check out the page Add or Remove Azure Role Assignments using the Azure portal from the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Apart from authentication and authorization, many services provide additional protection through advanced data security. Azure includes several built-in roles that you can use. Advanced Data Security implements threat protection and assessment. Threat protection adds security intelligence to your service. This intelligence monitors the service and detects unusual patterns of activity that could be harmful or compromise the data managed by the service. Assessment identifies potential security vulnerabilities and recommends actions to mitigate them. You can access these from the Advanced Data Security page for SQL Database. It's worth noting that the corresponding pages for MySQL and PostgreSQL are similar. This part explores the specific configuration options available to each type of data store within Azure Relational Data Services. The overarching principle for network security of the Azure SQL Database offering is to allow only the connection and communication that is necessary to allow the service to operate. All other ports, protocols, and connections are blocked by default. Virtual Local Area Networks, or VLANs, and Access Control Lists, or ACLs, are used to restrict network communications by source and destination networks, protocols, and port numbers. An ACL contains a list of resources and the objects, users, computers, and applications that are allowed to access those resources. When an object attempts to use a resource that is protected by an ACL, if it's not in the list, it won't be given access. Items that implement network-based ACLs include routers and load balancers. You control traffic flow through these items by defining firewall rules. The following steps describe how a connection is established to an Azure SQL database. Clients connect to a gateway that has a public IP address and listens on port 1433. Depending on the effective connection policy, the gateway either redirects traffic to the database cluster or acts as a proxy for the database cluster. Note that Azure SQL Database uses a clustered topology to provide high availability. Each server and database is transparently replicated to ensure that a server is always accessible, even in the event of a database or server failure. Inside the database cluster, traffic is forwarded to the appropriate Azure SQL database. If you're connecting from within another Azure service, such as a web application running under Azure App Service, your connections have a connection policy of redirect by default. For example, the policy of redirect. After your application establishes a connection to the Azure SQL database through the gateway, all following requests from your application will go directly to the database rather than through the gateway. If connectivity to the database subsequently fails, your application will have to reconnect through the gateway, where it might be directed to a different copy of the database running on another server in the cluster. Okay, let's take a look at the connectivity from outside of Azure now. If you're connecting from outside Azure, such as an on-premises application, your connections have a connection policy of proxy by default. A policy of proxy means the connection is established via the gateway, and all subsequent requests flow through the gateway. Each request could potentially be serviced by a different database in the cluster. Denial of service, or DOS attacks, are reduced by a SQL database gateway service called DOSGuard. DOSGuard actively tracks failed logins from IP addresses. If there are multiple failed logins from a specific IP address within a period of time, the IP address is blocked from accessing any resources in the service for a short while. In addition, the Azure SQL Database Gateway performs the following tasks. It validates all connections to the database servers to ensure that they are from genuine clients. It encrypts all communications between a client and the database servers. It inspects each network packet sent over a client connection. The gateway validates the connection information in the packet and forwards it to the appropriate physical server based on the database name that's specified in the connection string. When you create your Azure database for PostgreSQL server, a default database named Postgres is created. To connect to your database server, you need your full server name and admin sign-in credentials. You can easily find the server name and sign-in information on the server overview page in the portal. This page contains the server name and the server admin sign-in name. Connections to your Azure database for PostgreSQL server communicate over port 5432. When you try to connect from within a corporate network, outbound traffic over port 5432 might not be allowed by your network's firewall. If so, you can't connect to your server unless your IT department opens up port 5432. A PostgreSQL database server has a number of configuration parameters that you can set. These parameters support fine-tuning of the database and debugging of code in the database. You can modify these parameters using the Server Parameters page in the Microsoft Azure portal. If you're familiar with PostgreSQL, you'll find that not all parameters are supported in Microsoft Azure. The Server Parameters page on the Microsoft website describes the PostgreSQL parameters that are available. There is a link to this document from the additional readings at the end of this lesson. PostgreSQL also provides the ability to extend the functionality of your database using extensions. Extensions bundle multiple related SQL objects together in a single package that can be loaded or removed from your database with a single command. After being loaded in the database, extensions function like built-in features. You install an extension in your database before you can use it. To install a particular extension, run the create extension command from the pgsql tool to load the packaged objects into your database. Not all PostgreSQL extensions are supported in Microsoft Azure. For a full list, read PostgreSQL extensions in Azure Database for PostgreSQL single server on the Microsoft website. You can find a link to this document from the additional readings at the end of this lesson. Let's talk about read replicas now for PostgreSQL. You can replicate data from an Azure database for PostgreSQL server to a read-only server. Azure Database for PostgreSQL supports replication from the master server up to 5 replicas. Replicas are updated asynchronously with the PostgreSQL engine native replication technology. Read replicas help to improve the performance and scale of read-intensive workloads. Read workloads can be isolated to the replicas, while write workloads can be directed to the master. A common scenario is to have BI and analytical workloads use read replicas as the data source for reporting. Because replicas are read-only, they don't directly reduce the burden of write operations on the master. This feature isn't targeted at write-intensive workloads. Replicas are new servers that you manage similar to regular Azure Database for PostgreSQL servers. For each read replica, you're billed for the provisioned compute in vCourse and storage in gigabytes per month. You can use the replication page for a PostgreSQL server in the Azure portal to add read replicas to your database. In order to connect to the MySQL database you've provisioned, you'll need to enter the connection information. This information includes fully qualified server name and sign-in credentials. You can find this information on the overview page for your server. Connections to your Azure database for MySQL Server communicate over port 3306. When you try to connect from within a corporate network, outbound traffic over port 3306 might not be allowed by your network's firewall. If so, you cannot connect to your server unless your IT department opens port 3306. By default, SSL connection security is required and enforced on your Azure database for MySQL Server. Let's now take a look at how you can configure server parameters for MySQL. Like PostgreSQL, a MySQL database server has a number of configuration parameters that you can set. You can modify these parameters using the Server Parameters page in the Azure portal. You can find more information about the parameters available for MySQL in Azure on the How to Configure Server Parameters in Azure Database for MySQL by using the Azure portal page on the Microsoft website. There is a link to this document from the additional readings at the end of this lesson. Finally, let's also look at read replicas for MySQL. This feature is also similar to the one that is available for PostgreSQL. You can create up to 5 read replicas for a MySQL database. This feature enables you to geo-replicate data across regions and distribute the overhead associated with read-intensive workloads. Replication is asynchronous from the master server, so there may be some lag between records being written at the master and becoming available across all replicas. Read replication isn't intended to support write-heavy workloads. You can use the replication page for a MySQL server in the Azure portal to add read replicas to your database. It's important to note that the read replica feature is only available for Azure Database for MySQL servers in the general purpose or memory-optimized pricing tier. Ensure the source server is the one of these pricing tiers. In this lesson, we've learned how to provision and deploy relational databases using different types of data stores. You've seen how you can deploy Azure Data Services through the Azure portal, the Azure CLI, and Azure PowerShell. You've also learned how to configure connectivity to these databases to allow access from on-premises or within an Azure virtual network. You've also seen how to protect your database using tools such as the firewall and by configuring authentication. Hello, and welcome to this lesson where you will explore how to query relational data in Microsoft Azure. Microsoft Azure enables you to create relational databases using a number of technologies. These include Azure SQL Database, Azure Database for PostgreSQL, Azure Database for MySQL, and Azure Database for MariaDB. Imagine that you work as a developer for a large supermarket chain called Contoso. The company has created a data store that will be used to store product inventory. The development team has used an Azure SQL database to store their data. They need to know how to query and manipulate this data using SQL. In this lesson, you'll learn how to use these database services to store and retrieve data. You'll examine how to use some of the common tools available for these database management systems to connect to database services running in Microsoft Azure. This lesson focuses on using Azure SQL Database, Azure Database for PostgreSQL, and Azure Database for MySQL. If you are using Azure Database for MariaDB, the dialect of SQL is very similar to that used by MySQL. In this lesson, you will describe query techniques for data using the SQL language and query relational data. SQL stands for Structured Query Language and is used to communicate with a relational database. It's the standard language for relational database management systems. SQL statements are used to perform tasks such as update data in a database or retrieve data from a database. Some common relational database management systems, or RDBMS, that use SQL include Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, and Oracle. SQL was originally standardized by the American National Standards Institute in 1986 and by the International Organization for Standardization, or ISO, in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors include their own proprietary extensions that are not part of the standard, which has resulted in a variety of dialects of SQL. Now you'll learn about SQL. You'll see how it's used to query and maintain data in a database and the different dialects that are available. You can use SQL statements such as select, insert, update, delete, create, and drop to accomplish almost everything that one needs to do with a database. Although these SQL statements are part of the SQL standard, many database management systems also have their own additional proprietary extensions to handle the specifics of that database management system. These extensions provide functionality not covered by the SQL standard and include areas such as security management and programmability. Microsoft SQL Server, for example, uses Transact SQL, which is sometimes referred to as T-SQL. This implementation includes proprietary extensions for writing stored procedures and triggers, application code that can be stored in the database, and managing user accounts. PostgreSQL and MySQL also have their own versions of these features. Some popular dialects of SQL include Transact SQL, T-SQL. This version of SQL is used by Microsoft SQL Server and Azure SQL Database. PG-SQL. This is the dialect with extensions implemented in PostgreSQL. PL-SQL. This is the dialect used by Oracle. PL-SQL stands for Procedural Language SQL. Users who plan to work specifically with a single database system should learn the intricacies of their preferred SQL dialect and platform. Let's look at SQL statement types now. SQL statements are grouped into two main logical groups. They are Data Manipulation Language, or DML, and Data Definition Language, or DDL. You use DML statements to manipulate the rows in a relational table. These statements enable you to retrieve or query data, insert new rows, or edit existing rows. You can also delete rows if you don't need them anymore. The four main DML statements are select, which selects or reads rows from a table; update, which edits or updates existing rows; delete, which deletes existing rows in a table; and insert, which inserts new rows into a table. The basic form of an insert statement will insert one row at a time. By default, the select, update, and delete statements are applied to every row in a table. Let's begin with an example of a select statement. This code selects all rows from the table named MyTable, where myColumn2 is equal to the value of Contoso. The function of the from clause is to specify the table to query. You usually apply a where clause with these statements in order to specify criteria. Only rows that match these criteria will be either selected, updated, or deleted. If a query returns many rows, they don't necessarily appear in any specific sequence. If you want to sort the data, you can add an order by clause. The data will be sorted by the specified column. In this example, the order by clause is placed after the from clause in the query. You can also run select statements that retrieve data from multiple tables using a join clause. Joins indicate how the rows in one table are connected with rows in another to determine what data to return. A join condition defines the way two tables are related in a query by specifying the column from each table to be used for the join. A typical join condition specifies a foreign key from one table and its associated primary key in the other table. Specifying a logical operator, for example equal or not equal, to be used in comparing values from the columns. This query shows an example that joins two tables, named Inventory and Customer Order. The query retrieves all rows where the value in the inventory ID column in the inventory table matches the value in the inventory ID column in the customer order table. You join two tables together by using the join operator, which is placed after the from clause. SQL also provides aggregate functions to perform computation and aggregation operations. An aggregate function calculates a single result across a set of rows or an entire table. This example uses the min function to find the minimum value in the myColumn1 column across all rows in the myTable table. A number of other aggregate functions are available, including max, which returns the largest value in a column, average, which returns the average value, but only if the column contains numeric data, sum, which returns the sum of all the values in the column, but also only if the column is numeric, and finally count, which counts the number of rows returned by a select statement. This example shows how to update an existing table row using the update statement. First, the update command specifies the table to be updated. Then, using the set command, it modifies the value of the myColumn2 column, but only for rows where myColumn1 is equal to the value of 3. All other rows are left unchanged. The delete statement is used to remove rows by specifying the table to delete from. Then you use a where clause that identifies the rows to be deleted. It's important to note that SQL doesn't provide "are you sure" prompts, so be careful when using delete or update without a where clause because you can lose or modify a lot of data. If you omit the where clause, an update statement will modify every row in the table, and a delete statement will delete all the rows in the table. Finally, let's look at the insert statement. The insert statement takes a slightly different form than the others. You must specify a table and its columns using an into clause, followed by a list of the values to be stored in these columns. This example inserts a new row into the myTable table. Standard SQL only supports inserting one row at a time. Some dialects allow you to specify multiple value clauses to add several rows at a time. We will discuss SQL dialects in more detail later. Okay, let's take a look at DDL statements now. You use DDL statements to create, modify, and remove tables and other objects in a database. These objects can be tables, stored procedures, views, and so on. The four main DML statements are create, which creates a new object in the database, such as a table or a view. Alter, which modifies the structure of an object. For instance, altering a table to add a new column. Drop, which removes an object from the database. And rename, which renames an existing object. It's important to note the drop statement is very powerful. When you drop a table, all the rows in that table are lost. Unless you have a backup, you won't be able to retrieve this data. Let's look at an example as to how you could create a new database table using the create table statement. The items to specify the details of each column are placed between the parentheses. These include the column name, the data type such as int for integers or varchar for strings, whether the column must always contain a value, which is written as not null, and whether the data in the column is used to uniquely identify a row, which is written as primary key. Each table should always have a primary key, although SQL doesn't enforce this rule. It's important to note that columns marked as not null are referred to as mandatory columns. If you omit the not null clause, you can create rows that do not contain any value in the column. An empty column in a row is said to have a null value. The data types available for columns in a table will vary between database management systems. However, most database management systems support numeric types such as int, an integer or whole number, and string types such as varchar, which stands for variable length character data. For more information, you should refer to the Microsoft documentation for your selected database management system. In order to query relational data in Azure SQL Database, you run SQL commands from tools and utilities that connect to the appropriate database. The tooling available depends on the database management system you're using. Now we will describe briefly the tools that you can use to connect to Azure SQL Database. You will explore these and other tools further in the readings and exercises at the end of this lesson. You can use any of these tools to query data held in Azure SQL Database. The Query Editor in the Azure portal, the SQL Command Utility from the command line or the Azure Cloud Shell, SQL Server Management Studio, Azure Data Studio, and SQL Server Data Tools. In order to use these tools, you first need to establish a connection to the database. To do that, you require the details of the server in order to connect to an Azure SQL database account. These details typically include the credentials, such as a username and password that has access to the server, and the name of the database to use on the server. You can find the server name for a database using the Azure portal. From the Azure portal, go to the page for your database, and on the Overview page, note the fully qualified server name in the server name field. Some tools and applications may also require a connection string that identifies the server, database, account name, and password. Select Show Database Connection Strings to access this information. The database connection string shown in the Azure portal does not include the password for the account. You must contact your database administrator for this information. The following readings in this lesson will walk you through the process of connecting to and querying a database using the most common query tools. The process itself is quite similar for each RDBMS, but you will need to use a specific tool depending on the type of database that you wish to connect to. For example, you can use the Azure portal to connect to an Azure SQL database. You can then select the query editor and create and run your SQL code. Or you could use Azure Data Studio, which is a graphical utility for creating and running SQL queries from your desktop. SQL Server Management Studio is also another tool that you can download and run on your desktop. To connect to a PostgreSQL database and run queries, you can use tools such as the pgadmin graphical user interface and the pSQL command line utility. There are a large number of third-party utilities you can use also. This example demonstrates the use of Azure Data Studio to execute a new query. Finally, there are also many tools available to connect to MySQL that enable you to create and run scripts of SQL commands. You can use the MySQL command line utility, which is also available in the Azure Cloud Shell, or you can use graphical tools from the desktop, such as this example using MySQL Workbench.